The basics of ice modeling are broken down into two areas. In the ice tree, we have the task for topology. Here are all the high-level compounds. And under tools topology, here are all the low-level nodes. So let's just have a look at some of the principles involved. I'm going to select the bottle and create an ice tree. Now I'm going to go and grab set topology, inside of which is actually just self with dot topology, dot topology being the new terminology for modeling. So I put that in there. I've actually told it not to do anything because it's just saying set topology. So I need to actually push something inside here. So I can go and get, say, a subdivide locally here. Well, it doesn't look as though it's doing anything, but it actually is. Inside here, it's actually asking for a polygon index. So if I have a look down here, oh, there it is. If I move the index around, you can see it's subdividing a single polygon. Now, if I want to do the whole object, I would have to go and get the index for the entire object. So I'll go and do a get data, and let's have a look inside the new attributes. So under the bottle, we have edge. At the bottom, I'll jump down and we can see vertex, and somewhere in the middle here is polygon. So I actually want the polygon index. This is the equivalent to doing something like the point position, and that would give you, a particle cloud, something like that. So polygon index and the index I pump into here. So now it's doing the subdivision on the whole object. Now, because this is ice, well, yes, okay, it's okay for me to do something as basic as this, but the benefit is being able to have the control, say, with an external object. So with this, I could go and put a condition in there. So only subdivide on a condition. If I would go and grab an if node, drop that in. Now you can see I have that Boolean switch there. And I can go get, say, a greater than. If I move the null, I want to actually control it with a null. I can do the greater than. What is it going to be greater than? Well, it's going to be greater than the position of the null, which is here in Y. I'll do, and let's just drop it on there. And there we go. So with the movement of the null, there we go. When it goes higher than 0, it's going to subdivide. Otherwise, it's not going to do anything. Well, while I have this if node with a true, I could probably do something else. So with the modeling operations, often you have to stack them up in a hierarchy, one on top of the other. But this way, we can actually build a number of operators in one graph. So if I go back to my topology here, I could say, well, I want to merge these two objects together. I can go merge topo side here and pop that in. Now it's going to ask me for what I want. And here's a quick way to do like the get topology, and I can just pick which one I want. So okay, I can say, well, I want the jar, and put that in. And what else do I want? Well, if I get another get topology, I'll say get one of the lids. I'll just pick the little fella. There we go, and pop that in. And if I switch to wireframe, you're probably going to see it a little easier here. So it's saying from topo input or node transform. I'm just going to put inside here. So as the thing goes below, there we go, it's now adding and merging the topology of the lid to the bottle. So if I were to select, you can see it's now one object. Well, I actually want it the other way around, so I can switch the conditions in the if node. So just showing a nice little bit of the control there. Well, as I move the null around, perhaps I could even use that to place my lid. And that's where things like the topology here, if I use from topo input, that's actually going to keep it where the origin was, or the original lid in this case, and now I can actually use another object, and I actually want to use the null. So if I go and grab the null inside here and do the full name, as I move the null around, the merge takes place on the position of the null. But obviously if I go below, it's going to unmerge and use the subdivision instead. If I duplicate the null, I'm actually going to use this one as another control object. So I'll go back and just pop the lid back down on here. And I'm going to go and get a high level node now. If I go in here and search for extrude, what have we got here? Apply extrude along an axis. So if I add this now, inside here it's got me different ways for me to do an extrusion. Now this is slightly different from the normal sort of organic modeling tools you would expect. This one demands like an array or an integer. So if I were to do, say, a string array, it says, well, what does that mean? Well, if I type in a number here, let's say 122, whatever. Okay, there we go. So that is, like before with the subdivision, that's saying, if I go 122, 123, there we go. You can see I can now use an array. I can say 123 and 124, and now I've got the two items here. So that's one way of being specific about my extrusion, but as we've seen with the control objects, I can use that using things say like an is element. And the is element you can see is going down here is element. I can use a test. Now I took the polygon test polygon inside null. That was a test inside null looking for point position, and instead, just as we've seen using the point index, polygon index, you can also use the polygon position. So I just changed that and resave this out as a new compound. And now if I pop this into the is element, I need to go and grab that null and say that's my control object. So now if I were to zoom in a bit in here, I'm actually going to just change this to say a rings, something like that. And inside here, so is element is now going to be my control object, and that's what I want to use for my extrusion. So now anything inside that null is going to get extruded, and if I were to just perhaps reduce it slightly like that, there we go. You can now see I can control the object extrusion by the movement of my null. So I've just been showing you some of the low-level nodes and one or two of the high-level nodes. Now this ice modeling really isn't about replacement of the current organic modeling tools. It's about the control we have using multiple objects, or using a graph, or changing the inputs on a large scale. So let's have a look a bit about that. When I've been dealing on the bottle, I've actually, all of this set topologies, it's rebuilding the topology each time. So things like the index array is changing. So what it might be better to do is start to introduce some of the concepts of things like an empty mesh. And what that allows me to do is to do all the operations as set topology on the empty mesh and not actually change the original object. There is another shortcut I could do, and that's go in here. I'm going to type in. So I've just added an operator to the empty mesh, and here I can just do clone polygon mesh. So if you want, you can always just say, well, actually, what I really want to do is take that and have my own starting point, and you can use clone polygon mesh. I could also use create multiple copies. And here I create copies from the polygon mesh instead of the clone. If I just pop that in there, again the same one, I can use the original one here. I'm actually going to pin that one open. I don't need the clone actually, I'm just going to use the copies for now. And it says how many copies do you want multiple copies here. And here you can see the offset. I can just play around with the offset. It's pretty interactive here. So I'm just using a numeric input here, but as you can see we're using multiple control objects, and that's really where ice modeling comes into its own. If I were to go in and say grab, instead of an empty polygon mesh, I could actually go and get the point cloud and bring an empty one of those in. Or I could go in and create a pre-existing pattern. So here I can go and get, say, a grid. I can change the number of inputs, maybe change the scale a bit. And in the same way that I use nulls to use my control objects, I can use this point cloud grid and use this as my template for the distribution. So now I can distribute the bottles here, change the scaling and that sort of stuff. So however complex my point cloud can be, I can use that as my distribution model. So starting from a very low level nodes, building up to the high level nodes, ice modeling is designed to be able to give you the control, changing the operators inside a graph, changing the inputs over time, or using multiple elements together to create more complex scenes. Here is a practical example for ice modeling. Here are the normal elements that were made from just the organic modeling tool set that we have. And actually here is the wheel. This is the result of the wheel, and it uses the create copies from polygon mesh. It also uses here the wheel roots, so that if I were to say duplicate one of these nulls and move it along, it automatically adds that wheel. So it's using a wheel just for the placement of the part of the final result, but also adds a nice little set of controls there. If I delete that, it removes it from the group, and therefore it's automatically being read from there and ultimately delete from there. So once these are combined, if I just go here and just hide that, we're left with, we'll see the wheels result, and we get the chair result. Here we go, in all its glory. If I have a look at this, it's actually using the merge polygon meshes, but it's also merging the text projections, and here we have merge material ID. So it's identifying all the original materials and then setting up how they should be distributed in the final mesh. So it's showing you the propagation of the UVs and materials to the final result. Now the same process was used for the desk in the room, and if I go just show you one of the desks here, here's the desk result. Oh, it's up here. There we go, and it also had its own UVs. We'll get rid of that now, so yeah, we can see how it was constructed. If I go into the final result side here, so it's also got a constraint acting upon it, and here we can see the copies. If I go, it was using a polygon mesh for its template. So now if I were to just bring this out, as we've seen before, the number of copies are based on the point cloud, and then you can see the distribution going along here. So this is a practical example of how to populate, in this case, an office with the individual elements, and how you can go back at any stage and make significant changes. Actually, here's a bit of fun. The materials are managed through a library here, and so we're just using like a string to identify each individual material, and here's the material ID. The benefit is this, if I go into the texture decal mode, is when dealing with say passes, you have to set up all the material overrides and such, but this way you could actually I'll have just one or two overrides, and we can switch between, say, the hardware rendering mode, the mental ray mode, and all it's dealing with is changing the material library setup rather than having to do the overrides on the whole thing. So a nice little side bonus there. Another one is to show that once you've set this up, it's not just a matter of populating it and letting go. Here we have a plane which is controlling another ice tree. If I probably zoom in a bit here. Actually, I'll switch back to texture decal. Now, if I were just to rotate this, this is actually going to be working on the poly mesh of the result. Now, when it pushes in, it's not actually going to be, if I put it here, just scaling or anything. It's actually pushing the vertices, so it's keeping the side panel in the right dimensions, actually just squishing on here. So you'll see how it's propagating all the way down here, and how it's using a push on the side and then squeezing up the final result. So even on the final mesh, you can still act upon it, because indeed it's just a bunch of points. It just happens those points were driven and created by ice modeling. Strands can be used with ice modeling. Here's my curve, my little star. I'm going to go and get a new empty point cloud, and I'm going to create an ice tree. What I want to do is just type in here curve. There's create strand from curve. So I'll pop this inside here. I need to go and get my circle, bring that in, and that's, here we go. So now how many segments for my curve? Number up here. So now I've created my strand. What I can do is then do a bit of ice modeling on that strand. So if I go and create an extrusion, yeah, I can create an empty polygon mesh and create its own ice tree, and now create an extrusion along that strand. So this one's also going to ask for the point cloud. So here we know we've just created that one here, and bada bing, bada boom, we have an extrusion. The number of segments around, I also can use the original strand inside the point cloud for side here. So oops, this one, and create, instead of 69, I can create more and more detail in my original strand itself. I guess ironically I could even use the original curve for its shape. So if I were to go in here and grab my circle, it's this one's just using a circle. I could create a custom shape, and here is my star shape, and pop that into the custom shape name. So there we go. Now it's actually using a star. So the cross section, if I go back to my original one here, let's just reduce this so we can see it probably a bit better. There we go. On one end here, it's actually using that as my cross section. So any number of shapes can be used to create a nice effect. All you need is the strand that creates strands from curve. And here we've got a nice looking loft. So given this, I mean, I've just used one strand. Here is an example. If I just hide these guys, is to have a look here. Now this is multiple strands. I don't need my circle. Oh, I guess I could keep my circle now, actually. I actually put some animation in. If I look at this, again, it's using the extrusion along strands. And it's just got a circle here, but if I change that one, I used the star again, and I had a little bit of fun. So I was back at the cinema, my Pearl and Dean days back in England, and had a little. There we go. Yep. Strands and ice modeling. That's a bit of fun there. The power of ice modeling can really produce some amazing setups. Here we can see a section of track. We've got the cross section lofted along a curve. So if we have a look at here, create strands from curve. We can change the number of sections. You can see that the barriers along the edge are also changing accordingly. Kind of cool thing is here is the actual barriers themselves. They're working on a loop of the polygon ID. So as I move this around, it's going to find the closest polygon and then move itself to there. So this is really showing you some of the amazing controls that we can have here. I can use this to change the positioning of the track. I can also use it, there we go, because it's controlling the curve and the banking, this type of sections. If we also have a look underneath, we have the column support. If I have a look at this, here is the number of columns it's using, and we can create the number of columns. We can also see the maximum height, so we can really see how as I move this, everything is procedural and tracking as it should. So here it's dynamically putting all the columns in place, which is very handy indeed. Now the wall is made up of a single section which has been duplicated and then placed along this track, and here I can use a bit of fun. I can change the angle as the things swoop by, so play around. So even though this is a single mesh, each of those has obviously its own, the placement has its own coordination along the track. So with curves, with ice modeling, and with the using point clouds to define a lot of the setup, the power of ice with ice modeling is really something special. And now we have another great cube demo. Well, in fact, it's kind of a great cube demo, because here this individual object is controlling not only the position but holds the parameter to control the chunking of this cube. So as I scale it up or move it around, you can see the fracturing going on here. I can also play around with the inset of the fracturing, how they're held together. I can even use this object to start to blast my way through, or if actually all it's doing is just moving the individual elements. We've seen how a bunch of algorithms can be employed to use in a procedural manner to generate, in this case, fracturing, and using external elements and point clouds to be able to do the definition, and in this case create some fake shatter animation. Very, very nice example. One unique thing I guess you could say about ice modeling is that to create a piece of geometry, in this case like a primitive, you don't actually need to have anything pre-existing to do it. Here we're just using an array to be able to create this geometry. And it's the same principle for when we get, say, an empty polygon mesh. We can create an ice tree here and use the primitive mesh. I can just go and get the set topology, and here we have our different primitives. Here I can get my grid here, and it'll keep the same parameters each time. So a great way to be able to make complex custom primitives, maybe stairs, windows, that sort of thing.